Good afternoon everyone, welcome to my YouTube channel. So for today we are going to be proving some math. So if you are new, kindly like, subscribe and share for more so that A-level math becomes a walk in the park. So the question says that prove that A is a subset of B if and only if B complement is a subset of A complement. So how do we go about this statement? So firstly, we need to understand how subsets operate. So if we have our B, if we have our A is a subset of B, this simply means to say A is found inside B. In other words, the O of A is found in the inside of B. So whatever members are part of A are also part of B. That's the meaning. So now, when you look at this, we can simply say that if A should be equal to, let's say we have 1, 2, then your B should also contain the same numbers such as 1, 2, even more. Let's say we have a 3. So this simply means to say whatever members are found in A are also found in B. So we are going to use this proof. So we are going to use our A is a subset of B to go to where we want to go. It is to B complement is a subset of our A complement. So our proof is very simple. So what you're going to do is, in order for you to use this to go to that, first take your B. So what we are going to do is this. So we are going to say that let your X be equal to, what letter do we have here? Let your X be equal to a letter such as your B complement. Now what does this mean? When you say that X is a member of B complement, it simply means to say, if you are saying that X is a member of B complement, it means to say X is a member of excluding B. So it is all the members that are not in B. So meaning something like that. Now that means to say already that will say that your X must not be a member of B. Since X is a member of B complement, it cannot be a member of B like that. Then the other thing that we are going to do is, now since we have said that our X is not a member of B, now remember, your B is the bigger set. We said that if, let's say A is 1, 2, your B will be 1, 2, 3. Now all the members that are in B are also, all the members that are in A are also in B. So if a certain set is not part of B, it simply means to say that set will not also be a member of A, since our A is found inside B, and if X is not a member of B, it must not also be a member of A. That simply means to say also the X must also be a member of A complement. If it is not in A, it simply means to say, if it is not in A, it simply means to say it is a member of A complement, like that. So that means to say, as long as you have this and you have this, you can say that your X is we can say that our B complement, we are moving B complement, we also have this. So let's just write them. First we have our X is a member of B complement. We also have our X is a member of A complement. So we can join this by just saying that your B complement is a subset of your A complement. That's the first part of the proof. Let's try the other side. So for the second part of the proof, we want to use this side to go to A is a subset of B. So this means that the B, this time B is a subset of A, means that B is found inside A. So we have this type of an arrangement. So how are we going to do that? Just be taking the first letter, that's where you want to go. So you are going to say that your X must be a member of whatever your A is. Then what you are going to do is, already if X is a member of A, it means to say your X must not be a member of A complement. So your X cannot be a member of A complement. What does this tell you? Now remember, your X your x, if your x is not a member of A complement, if you see your A complement is the bigger set, your B complement is found inside. Already, this means that, let's say for example, if your B complement is equal to, let's say, just a 3, then that means to say already your A complement should also contain the number 3, since B complement is found inside A 3, maybe some 4 and among other values, but all the values that are in B complement should be found in A complement. So since we are saying that X is not a member of A complement, which is the more like the bigger set, it simply entails that X must not also be a member of our B. Then the only thing that will be there is that your X must be a member of X must not be a member of B complement. That means to say X must, if it is not a member of B complement, it must be a member of B, like that. Therefore, we can say that, uplifting this, we can have X is a member of A. We also have our X is a member of B. So if that's the case, we can just join them by saying that since X is a member of A and it is also a member of B, we can say that our A, beginning with the first letter A, is a subset of B, or A is contained in B. So we have proved both ways, so we can say that hence proved. So that is how you prove that. Thank you very much for watching my video. Hope you like, subscribe and share for more.